Okay, continuing with the non-pilot decision paper, here's question 2 from June 2013. It says the diagram shows the location of wind turbines at A, B, C, D, E and F. The number on each edge shows the distance in kilometres between pairs of turbines. And then part A says, showing the order in which you select the edges, use Prim's algorithm starting from A to find the minimum spanning tree for the 6 turbines. So we're starting at A, and the aim of Prim's algorithm is to find a way of connecting all the places as if it was with cables, so that everywhere has power. Prim's algorithm says start where it says and go to the nearest place so long as it doesn't make a cycle. So we're starting at A, where's the nearest place? Well, I can get to B or I can get to F. Which one's nearer? Well, F is, so I'm going to go from A to F. And I'm going to write down that the first edge that I added was AF. And then I just repeat it. So I say, where can I get to from all the places I've been already? Well, I've been to A and F, I can get to B or E. Which one's the nearest? Well, it's 0.8 either way, so I'm going to add in AB next. I'm going to have a look at all the places I can go to. Well, I can go to E or I can go to C. Which is the nearest one? Well, E is the nearest one, that's 0.5. So the next edge I add in is B to E. And I just keep going. Where's the nearest place I can get to? Well, I can get to C or D. C is 0.8, D is 0.8, so it doesn't matter which one I go to. I'm going to go BC. And then finally, what's the shortest way of connecting D? Well, that's the 0.5, so that's CD. Part B asks us to state the length of my minimum spanning tree. Well, for that, I'm just going to add up the weights of my edges. So that's 0.5 plus 0.8 plus 0.5 plus 0.8 plus 0.5. So I get that as being 3.1 kilometres. So part B is 3.1 kilometres. Part C asks us to draw our minimum spanning tree. Well, it's just going to look like it did on the page, but we have to do this because the examiners aren't going to be looking at the question, they're going to be looking at our answer parts. So we need to give them what our tree looks like. And in this case, it looks like an E. Now, depending on the order that you do this, you're going to have a different shape. There's lots and lots of different trees. You could have this as being a tree, or you could have a backwards E or a backwards S. They're all fine. And that's how you do question 2. Question 3 is very unlike any questions which have come up before. 200 wind turbines to be arranged in rows with a gap of 500 metres between each turbine. The rows are 800 metres apart. Each turbine must be connected either directly or indirectly to the mains electricity grid by cabling. The mains electricity grid is 2 kilometres from the nearest turbine. The diagram shows part of one possible arrangement. So you can see our distance vertically is 0.8 because the distance between the rows is 0.8. The distance horizontally is 0.5 because the distance between turbines in a row is 500 metres. Part A says if 200 turbines to be situated with 100 turbines in each of 2 rows, show that the minimum length of cabling needed is 101.8 kilometres. So what we've got here is we've got 2 rows. In my first row, I've got 100 turbines. In my second row, I've got 100 turbines. And then I've got my mains, which they need connecting up to. So the question is, how is the minimum length of cabling 101.8? Well, if I think about this, I've got 100 turbines. Well, here I've got 5 turbines. I need 4 bits of cabling. If I had 3 turbines, I'd need 2 bits of cabling. With 100 turbines, I need 99 bits of cabling. So for one row, I'd need 99 times 0.5. I'm going horizontally because connecting them horizontally would be shorter than connecting them all vertically because 0.5 is the shortest distance. Because we've got 2 rows, I'm going to have to do this twice, and then I'm going to have to add on the 0.8 for connecting the rows together, and I need to add on the 2 for the 2 kilometres back to the start. So when I do this sum, 2 times 99 times 0.5 plus 0.8 plus 2, that gives me my 101.8 kilometres. Find the minimum length cabling needed if 200 turbines to be situated with 50 turbines in each of 4 rows. Well, now if I've got my 50 turbines in my rows, we're going to have 50 in each row here. And now I've got 4 rows. and I still need the 2 kilometers of cabling to connect them up to the start. So we know that in each row I'm going to need 49 bits of cabling because we said we needed one less than the number of turbines. We're still going to connect all the ones in the rows first. So here we've got 4 rows, we're going to need 4 lots of 49, and each bit is 500 meters. So we're going to multiply that by 0.5. Then I'm going to need to add all the bits of cabling to connect my rows. That's going to be 1, 2, 3 bits of cabling. So I need to add on 3 lots of 0.8. I need to add on the 2 from the start. So we're going to do the sum 49 times 4 times 0.5 plus 3 times 0.8 plus 2. And you can just type that straight into your calculator. And we get the answer 102.4 kilometers. Part C says a company is building a new wind farm and it has to decide on the layout of the turbines. Use parts A and B to advise the company. So you can see that with 2 rows we needed 101.8 kilometers, but with 4 rows we needed 102.4 kilometers. So the fewer rows, the less cabling we're going to need. Ideally you'd want one big long line, but the advice we're going to give them is the fewer rows the better.